Hey everyone, in this particular video, I am going to talk about singular value decomposition. I have put a very tiny program, it's just a command how to use SVD. In this particular video, I am going to convince you what SVD does. So singular value decomposition sort of tries to decompose an image such that those singular values, they sort of indicate the kind of content that is there in the image. Okay. So, it is applicable to all sorts of data, but the images are much more convincing, I thought. Okay. So what I'm going to do now is let me just create some 4 images. So I have taken open paint and I have in this particular 500 cross 500 pixels. That's what I have selected in the entire thing. Okay. In the bitmap. Okay. So now what I'm going to do, wait a second. Am I sharing the right screen? Oh, yes. Okay. Okay, so now what I'm going to do, let me just draw something simple. Okay, so I will draw a box and let me paint this box red. Okay, let me paint this box here red. Okay, then let me create one more triangle. Okay, let me keep it. Oh, what just happened? Okay, now let me take something like this. Okay. So see here, there is just red there, there's a black triangle, and then what else do I have? Yeah, there's one more sort of square. So in this particular thing, let me okay, another triangle. We fill this one with okay, different color. Okay. So that's an abstract image. Okay, that's abstract image, I should say, all triangles. Okay. Fine. Now, what sort of information does it contain? So most of it is right. Then there are other two colors, right? There is buff and there is some black. Okay. Now, what I will do is I will file and I will save this thing as BMP image, bitmap image. That would be a 256 color bitmap. Okay. And the name I would give this is a 11. Okay. 11.bmp. That's the name I would like to give this. Okay. Okay. And yes, go ahead. I saved this particular image. Okay. So some colors got bad, but anyway, this is my first image. See the size of this image. It's 245.2 KB. Okay. Now let me add some more content to this. Okay, I will take the pen and I'll take some color blue or something and I start scribbling on this. Okay. Let me just start, scribbling on this. Now that's some information, right? Should I have one something neat? Okay. Anyway, fine. That's an information. Now that's a second detail, right? That's a second level of detail. You can see here file size is still it is showing 245.2 KB because irrespective of what's the content, a BMP takes in 8 bits per pixel in 256 color format. I will save this particular file. Save this. Wait a second. Should I let me go ahead and let me okay. So I take two colors. See here, did you observe? I took two colors here for this whole thing. Okay. Two colors. Okay. File. I will save this as save as a BMP image once again, same space, but this time I will call it as a 22. I feel that this contains much more of an information. So let me save it as 256 colors bitmap. Okay. Now what I will do for the third thing, what I will do, let me go a bit more into this. Okay. What is this new tool? What does it do? Wonder what does it do? Okay. Now I will take one more color, maybe something like a yellow, and let me again scribble more. Okay. So now compared to the second image, this third image contains much more of an information, right? Don't you think so? It's much more colors, much more scribbling. And because every scribble, every point which I do here, you need to specify the location, right? So this third image contains again much more data compared to the second image. Okay, it contains much more data compared to a second image. Okay, so file, I will save this thing as a BMP image. Okay, and now I'll call it as a 33. Okay. Save it. Okay, so now I've created 3 images. Now where do these things come? Okay, so usually such a situation arises in where, okay, let me just show you my desktop itself. Okay, let me show you my desktop itself. Let me minimize some pages, and you can see here. Do you see my desktop here? Now you can see on this particular extreme left top corner, that's all, smoke gray color that's there. That's not much of a detail, but as and when you come here, you can see, do you see the sudden changes in the color, the subtle changes in the color, the shading and all the things. So this is a place where there's lots of details, and this is a place where there is less detail. So the images which I created just now, that's what they are symbolizing. So few of the sets, the first image contains lesser detail, second image content more detail, third image content even more detail. Now can you see my MATLAB? Okay, now you can see my MATLAB. So what I've done is those images you can see are pasted in this particular folder only where my MATLAB is currently operating. Okay, in that particular folder. And what I'm going to do now, let me read this particular thing using the command imread 11, 22, and 33. Okay, so I had some other program, so let me just rub this. It's not necessary, I guess. Okay, now keep a look at the color space. Okay, BMP. Okay, these are BMP 2256 color BMP images. Okay, now what does a singular value decomposition do? Okay, singular value decomposition of an image is sort of returns as three matrices, right? See here the name given F, G, and H, which in your notebook you studied as U. Then this the whole summation thing, right? That was a singular matrix. First there is a matrix U, then there is a matrix E, and then there is the singular value matrix. Now, what are singular values? Singular values are, say you have this particular matrix I, which is that of an image. If at all it takes I multiplied by I transpose, okay, or sorry, I transpose multiplied by I transpose multiplied by I, okay, I transpose multiplied by I. Now, if at all I take this particular image, I transpose multiplied by I, then I find the eigenvalues, okay, and then I take the root of them, then I arrange them in decaying order as diagonal entry in a matrix. That becomes the singular values. Okay, so that if at all you take U multiplied by this E multiplied by V transpose, you will get the original image itself. Okay, now shall we go ahead and do this? So this is SVD sketch. Okay, it is meant for images, sort of optimized. Okay, now let me just run this party. Okay, this I used a pad. Okay, now let me run this. Keep an eye on the workspace. Keep an eye on the workspace. Okay, so see, I evaluate it, and what did I get here? I got a matrix F1, which is of size 500 cross 289, a matrix G1, which is of size 289 cross 289, and a matrix H1, which is of size 500 cross 289. Okay, that was my first image, a color one. Okay, now here, let me try this with the second image. Let me try the same thing, singular value decomposition for the second image. And what has happened? You remember, do you remember when I executed do we remember the first image had a content red and some yellow and blue, whereas the second image, it had lots and lots of scribblings. Okay, that is why the G1, which is the singular value for the first case, G1 was 289 cross 289 in case of the first image 11.bmp, whereas in the second case G2 it is 475 cross 475 because there was lots and lots of scribbling. Okay, because there was lots and lots of scribbling. Okay, now let me try it with G3 33, the third image. Okay, the third image, which is okay, what's the difference? The third image, what did I do? I again scribbled it. Okay, I again scribbled it with two colored more pens, right? I took some yellow and other things, and you can see here G3, the singular values. Earlier it started with 289 for lesser details, for larger details 475, and then for higher it went to 493. Okay, so what does it mean, by the way? It means that when you perform singular value decomposition, it's sort of those singular values. Okay. By the way, all these metrics, if at all I take F1, G1, and H1, I get the original image back. You want to check? Wait. Let us try. If at all I do IAM show unsigned integer 8, right? That's the data type because the data we had converted to double. Okay. If at all I do F1 multiplied by G1 multiplied by H1 transpose, let me see, do I get the original thing back? Wait a second, I'm waiting. Waiting. Once again, new share here. Okay. We got an image, but the image is not in color. Okay, the image is not in color, the image is in gray. Now you have to do some little bit of conversion here. Okay, but we can always recreate the image. You can cross check it with this with the numbers also. We can cross check it with the numbers also. Yeah, now let me come back. Okay. So what did I mean to say? I meant to say that the singular value decomposition, it sort of decomposes an image in such a manner that those singular values, they kind of reveal the information content in the image, that to decaying what's the contribution, what is the major contributing factor, what is the minor contributing factor, so that at some point, if at all you want to compress the data, maybe you can sort of compromise the thing. Okay. So that was one set. Now to make things better, let me take another set. Okay, I have another set of images here. Let me just show you. Let me take you to Paint. Okay, let me take you to Paint. Okay, earlier I have converted the images. I kept some simple images. Where are they? Here. Now I am in Paint. Now can you see? So I have another set of images here. Open. See this one. Okay, this is my image one. Okay, you can see this is much more simple, I think. Okay, 4-5 colors are there. This is image one. See the size, 500 cross 500, 245 KB. Then this one open image two. Okay, here I have scribbled it. Then open three. Okay, three, or sorry, I should use this four. Okay, I will open this four. Okay, this image, this is the third image. This you can see as least amount of information. Colors are missing, only few colors are white. Okay, white. Okay, so these are my images. Now let me run this whole data. Let me run this whole program for these images. Let me take you once again back to MATLAB. Okay, so let me, yeah, back to MATLAB. So images 1, 2, and 4. Okay, so 1, 2, and instead of this image 3, I had removed some part and I thought, let's not use it. Okay, so I am going to clear the workspace now and redo this once again. Okay. Why I did this is because, for this particular set, I was getting very, very smaller values. Okay. Now, did you observe one thing here? You observe one thing here. Now, G1, G2, and G3, they contain the singular value matrix. Okay. Now, observe here. All three images in bitmap image, they were 245 KB images. Okay, but you see the size of the singular value matrix. G1 is an 8 cross 8 double. G2 is a 400 cross 400 double. And G3 is a 15 cross 15 double. Now, what's with G3? G3 was the most pale one, right? Which one? Image 4 was the most pale one. Let me take you back there. Let us see what happened. Okay, let me take you to Paint and let us see what happened. Is it this so innocent looking image? Okay, now, but there is a catch here. Okay, now do you see this particular part? Now see, there is some information there. These are not boxes anymore. There is contours here. There are contours here. Okay, so to reveal that, and that too, there are different colors, right? So compared to image one, this particular image contains bit more of an information, not as much as image two, but then it has. Okay, so all those things have been conveniently represented by the singular value matrices. If at all I take F1 multiplied with G1 multiplied by H1 transpose, I get same 500 cross 500. If at all I take F2 multiplied by G2 multiplied by H2 transpose, still I get 500 cross 500. Okay, same is the case with H3. If at all I multiply them, I still get 500 cross 500. But then if at all I have to send the data individually, you send F1 as a data, F2 as a data, and F3 as a data. And you can see based on the information content, all of them are going to take different amount of memory, okay, for representation, or different amount of bandwidth for transmission. Okay, now let me just show you the properties of each of these. Okay, so let me just show you G1 now. How does it look? Now, do you see this G1 here? Wait a second. Yeah, now you can see these are my singular values. Now, G1 is a diagonal matrix whose upper diagonal entries are 0, lower diagonal entries are 0. And in mid, what we have are my singular values. What are the singular values? Singular values are the square root of eigenvalue of matrix image transpose multiplied by image. So major content, okay, major information is in the lower values. Higher values contain the less significant information. Isn't that cool? Now, I think that's a much fun or very useful application of singular value decomposition, and indirectly that of eigenvalues. Let me tell you, this matrix H1 is nothing but a matrix of the eigenvectors, okay, straight away of that particular image. And F1 is also related to eigenvectors and the image. So no, people keep on asking, what's the big deal? Why eigenvalues? Where do they use it, right? Now, if at all I tell some mechanical stuff, people don't understand. I think this images, right? Okay, I think I'm convincing enough here. I have shown you how to create an image in Paint also, how to bring it here, how to read an image, and I think that should do it. Now, let me just check if at all I had tried SVD instead of SVD sketch, what would have happened? Okay, let me do SVD instead of SVD sketch. Okay, I have made my point, the video is over, but just I'm trying to do this particular thing. And what just happened? It's not working. Okay, so for SVD sketch, if at all I go for simple SVD, you can see my G1 is still a 500 cross 500 double. Okay, still a 500 cross 500 double. If at all I do SVD sketch, so what it is going to do is special element for images, all the lower values. Okay, so they are going to be, retained. Okay, now let me just open this G1 matrix. How does it look like? Wait a second. I'm just interested in the diagonal entries. There you are. Now you can see here what has happened. Now, do you see when I do this, you can see a significant number, 9.94 into e to the power 4, 4, 4, 3, 3, 3, 531. Now, then see here, the values have drastically died out. Okay, the values have drastically died out for the diagonal entries, so that whenever you are representing images, you go from 0 to 255, right? 255 for white, 0 for black. If at all the numbers are in between, very, very significant, not so tall significant. You can see the numbers here. That is why when I use SVD sketch, it's specially meant for images. It sort of neglects all this not so significant values. And you can see for this particular case, which one? Wait a second. Even though I got a 500 cross 500, if at all I use SVD sketch. Okay, so let me run this thing once again. You can see instead of 500 cross 500, it's going to give me 8 cross 8, because only first 8 values were significant. Afterwards, the values were between 0 and the values went very small. Okay, so that was a video about the singular value decomposition. What does it actually mean? Okay, so I will make one more video now. This video went a bit larger. I will make one more video how singular value decomposition can be used for image compression. You can always use MATLAB. Okay, there is a nice image and whose compression they have showed using singular value decomposition. If at all you are interested in the video for image compression using singular value decomposition, put in the comments. Okay, now let me try it. Okay, so happy programming, be curious. Let me end this thing here.